In lesson 8.2, we're going to be graphing rational functions, and they are in the form of f of x equals p of x over q of x, where p of x and q of x will be some type of a polynomial, and the denominator, q of x, cannot be equal to 0. As always, we're going to start with a parent function, and in this case, it's going to be y equals 1 over x, and we have graphs that are in the form of hyperbolas, and they're just symmetrical open curves. So when we have a in the form of y equals 1 over x, the domain is going to be all real numbers, except x cannot equal 0. The range is also going to be all real numbers, y cannot equal 0, and our asymptotes will be x equals 0 and y equals 0. Here we can see our vertical asymptote where x equals 0. Here is our horizontal asymptote where y is equal to 0. So over here in the corner, you need to know that y equals a over x, that they're going to have the same asymptotes, domain, and range as y equals 1 over x. If I said y equals 7 over x, the 7 is going to be a stretch. It's not going to shift it. We'll look at shifts later on. So it's not going to affect our asymptote. In your homework, you're going to be asked to graph a basic rational function and then compare it to a parent function. And you'll notice that the one that we're working on, our numerator is 6. So that's going to be a stretch. So it's going to be further from the axis than our parent function of y equals 1 over x. So the first thing we want to do is to draw in our asymptotes, and this is just a basic graph. So it's going to be x equals 0 and y equals 0, just along here. And then I chose some points for x and solved for y for my parent function, and plotted those already. And notice I did not choose 0 because we cannot have 0 in the denominator. So I'm going to go ahead and try to draw in my line for my parent function, and then we'll continue on. Okay, so let's see what our graph of y equals 6 over x is going to look like. So again, we drew our asymptotes. We're choosing values for x to calculate our y, but we want to make sure our denominator never equals 0, and then we're going to go ahead and plot our points. So I chose a -3, so that's going to be -2. Then we end up with -3. 6 divided by -1 is -6. 6 divided by 1 is 6. 6 divided by 2 is 3, and then 2. So we're going to plot our points and connect them. All right, so I plotted the negative values, so we'll go over to the positive values. We go over 1 up 6, right about there. We go over 2 up 3, and then over 3 up 2. And it's going to get close to our asymptotes, our green dashed lines. So the red is our graph of our parent function, and the purple is the one where we had a stretch of 6. All right, on this slide we're going to translate, and you should be familiar with h, and we know that that's going to shift right, and we know our plus k is going to shift up. But let's see what happens to the asymptotes. Okay, our vertical asymptote is going to be x equals h because we're shifting right. So if I have a graph and we shift over 2 places, then whatever that shift was, the h, that's going to be my new line. The one thing is we can't have a denominator equal to 0, remember, so x cannot equal h. So x cannot equal h. And that would be if I had, if h were 3, and if x were equal to 3, 3 minus 3 of course is 0. So that is why x cannot equal h. And then for our our horizontal asymptote, it's going to be y equals the k value. And we'll discuss why that happens in class. All right, so let's try one. So we just said the vertical asymptote is x equals h, and my h value here happens to be 1. So our vertical asymptote is going to be x equals 1. So we're going to go ahead and draw that in. And now we're going to look at our horizontal asymptote, and that is going to be y equals 2. So we're going to go ahead and draw in that line. The next thing I want you to notice is that we're going to have a different placement because we have this negative. So it's going to indicate a reflection and change the location of our graph. Okay, also we're asked to state the domain and the range. So the domain is going to be all real numbers except x cannot equal 1 because we can't cross our asymptote. And the range is going to be all real numbers, although y cannot equal 2. Now we're going to choose some values for x and plot those and see what we end up with. All right, let's say we choose -2 as our value. So then we end up with, add the opposite, -3 over -3 is 1, and 1 plus 2 is 3. And then let's put in a 0. Now we can put in a 0 as long as our denominator does not equal 0. So -3 over -1 plus 2 is going to be equal to 5. And I'm not going to work out the next 2. We'll just say when we put in a 2, it's going to come out to -1. And we put in a 4, and it comes out to 1. And then we're going to plot these points. Okay, remember when we started off and I said we had this negative, so we were going to end up with a different placement of our graphs. So before we were working over here and over here, so we're in a different spot. And because I had only 4 points, I only end up with 2 and 2. But because we know what our asymptotes are, in general, we kind of know what our graph is going to be. It just has to go through these lines and get closer and closer to our red and our blue lines, right? All right, we have one more example and then we'll be finished. All right, so this one looks a little bit different, but it's not too crazy. Let's start off with the domain. If we look at the denominator, remember we don't want the denominator to be equal to 0. So the domain can be equal to all real numbers except x cannot be equal to -2 because -2 plus 2 would be equal to 0. Then we're going to look at our range, and our range is basically going to be a ratio of the x values. So if I put a 1 here, 3 over 1 is 3. So our range is going to be all real numbers except y cannot equal 3. And we'll discuss why that works in class. Then we're going to move on to our vertical asymptote, which has to be x is equal to -2, and I got that from my domain. And our horizontal asymptote will be y equals 3. So now we're going to make our table of values and graph. All right, so I drew in my vertical asymptote of x equals -2, my horizontal asymptote y equals 3, and then you can see at the top I had messed up a sign in my equation. It's 3x minus 6, so I rewrote that. So then I'm going to sub in some values for my x. Whoop, I forgot to put my x here. Okay, so we're going to sub in, let's say, a -6, a -4, a -1, and let's say a +4. Okay, so we're going to put in a -6, -6, and when we do that, we end up getting an answer of just 6. We end up with -24 over -4. Then when we put in our -4, it comes out a 9. When we put in a -1, we end up getting a -9. And then finally when we sub in our 4, and I haven't been putting them in, trying to save some time, whoops, put in our 4. So 12 minus 6 is 6, and 6 divided by 6 is 1. Sorry, I should have put those all in there. All right, so we subbed in our values, we solved, we have our table, and now we're going to plot our points. All right, so remember we're starting from the origin. We're not starting from the any place on our asymptotes. That's just not where our line is going to cross. So I went over -6 up 6, and then I went over -4 up 9, and then we know that this line is going to get close. And then I went from the origin, we went -1 down 9, so here's this point, and over 4 up 1, and we're not using the yellow point, that's just my origin, and then we're going to graph our second line. And that's it.